All right, we are going to go ahead and get started. I know you guys have probably been hearing me say this a lot, but I have to keep saying it in case we have some new people in the audience. But if you're in the audience, we'll take some questions at the end. I'll pass around the microphone so we make sure we get these questions on the live stream as well. And if you're joining us on the live stream, over in the sidebar of the live stream, you can go ahead and click that join discussion button to join our Discord channel. With that, I'm real excited about this one. I'm a big fan of GraphQL. We're going to hear from Netflix's Paul Baker today on GraphQL with Spring Boot, like Netflix. Take it away, Paul.
All right, so yeah, we're going to talk about GraphQL and specifically how we do GraphQL at Netflix with Spring Boot. Who of you were at Dan's talk yesterday about GraphQL? All right, very good. So this is going to be kind of the perfect build-up because Dan did a really good job explaining kind of the basics of GraphQL and how schemas look like and things like that. While I'm kind of glossing over these things, and I'm going to dive into code pretty soon and just kind of give you a feel of how it feels and looks like to build a GraphQL service with Spring Boot. So these two things together would give you a really nice overview, I think. All right, so my name is Paul. I'm in Java platform at Netflix, and I've been doing GraphQL for the last, 3-4 years or so since Netflix got started with GraphQL. I'm also a Java champion, and I also am one of the first authors of the DGS framework, which is the GraphQL framework that we're going to play with today. And this photo is kind of random, but it is just outside of the city of Las Vegas, like 30 minutes from here. If you haven't been there, you should definitely go and visit. All right, GraphQL. What is so special and what is so different about GraphQL? And it is very easy to kind of compare it to REST because everyone knows and understands REST. So the first really big difference, and it is key to everything, is that you must have a schema. Every GraphQL service has a schema. And that immediately sets it apart from what you have with REST, because with REST you don't have a schema. Or at least it is very, very optional if there's some sort of schema that you use. With GraphQL, you always have a schema, and that gives you a lot of flexibility and a lot of power. Besides having a schema, which obviously communicates kind of the API that you have in a very detailed way, when you send a query to a GraphQL service, you have to be specific about what data you want to get back from your query. So you have to do field selection. So you can't just say, give me all the shows, and somehow your service dumps all the show data on you and you can do whatever you want with it. No, you have to say specifically, I want to get the title and I want the name of the authors or the directors of a show. The benefit of that is that you don't do overfetching. So you don't get more data than you actually need. If I'm building a UI and I only need show titles, that's what I'm asking for. I don't get more data than I actually need. Now that seems kind of a trivial thing because bandwidth is cheap anyway. But it also gives you a lot of flexibility. So it makes the GraphQL API super flexible. The problem with REST is that as soon as you start kind of getting into the weeds of optimizing for specific use cases and devices, typically you have to build a REST API specifically for your iOS app. And then another one specifically for your web app, because they need different data at different points in time in their UI. That's a lot of work. And if you don't do that work, you kind of have a mediocre API for all of them, right? It doesn't quite work for any of them. With GraphQL, because it's so flexible and because of the schema and the field selection, you get that flexibility completely out of the box. Now, typically, you would use GraphQL over HTTP. That is kind of sort of the standard. And that means that you can use any HTTP library on any platform, on any language, to consume a GraphQL service. It's super easy. It's basically just doing the same thing as calling a REST service. It's just JSON. There are like higher level clients as well. So if you get more into the GraphQL space and you build, for example, an iOS app, there's specific iOS clients that just make it easier to build GraphQL clients. Again, because that schema is there, but that's completely optional. Now you can also use GraphQL over other transports. WebSockets is pretty common. If you want to do pushing from your server to your client, WebSockets is a really good thing to have often next to your HTTP endpoint. But typically, at least you have HTTP, and it means you have one endpoint / GraphQL, which you typically use over HTTP post. Now, I already talked about the schema, and we have to understand at least a little bit of the schema semantics. So on any GraphQL service, you would always have a type query. That's always there. And the query defines what fields, what queries your service supports. So that's kind of the data fetching side of your API. So I'm defining my schema that I have a shows query. And in this case, it returns a list of show. Show is, of course, a custom type. So I have to define it in my schema. And I say that show has a title of type string, and reviews, which is a list of review. Review, another custom type. It has a submitted date string and a star score of int. So we have some basic types and we have our custom types. You have to define all the custom types. Now, given this schema, we can run a GraphQL query, which you see on the right-hand side of the slide, where we ask for, okay, give me shows, that's our query. And on shows, I want to get title and the star score on reviews. See that I can't do just give me shows. That just won't work. It's not a valid GraphQL query. I also can't say I want shows and reviews. Now I have to be specifically saying I want star score from reviews. Given this query, we get JSON back, and that contains our shows query field, and we get all the data basically that we asked for. And now notice that in the reviews, we only get star score and not submitted date because I didn't ask for it. So no overfetching. This is all very, very nice and pretty simple. Now at Netflix, we don't just build like single GraphQL services. They actually work in a complete ecosystem of microservices. From the perspective of a device, so let's say I have Netflix on my phone, from the perspective of that phone or the person building the UI on the phone, we just have this giant federated GraphQL schema that contains all the queries and all the data that we have basically. It doesn't matter from their perspective where that data is actually coming from if you look at our backend architecture. So they could write a query that asks for, give me the Lolamo, which is the list of movies, I'll get back to that, with titles of shows and the artwork URLs for every show. Now in fact, this actually goes to a federated gateway, and if you look at like the backend services, we see that actually those different parts of the data, so the title and the artwork URLs, actually they are actually coming from completely different microservices. So these microservices are all Spring Boot services, and we call them DGSs, Domain Graph Service, but it's just a Spring Boot application with GraphQL in it. And we see that the Lolamo DGS is responsible for the type show. So the Lolamo DGS can give me show titles, but then the images DGS can actually say, well, I want to extend the show type, and I'm going to add an artwork URL field to it. Now, because I'm getting a query in the gateway that asks for both title and artwork, the federated gateway is going to write a query plan that then calls out to those two different services, get a result from both, and combine it back to a result that goes back to the client. So that all completely happens transparently from like the consumer side. This is just how we can structure our backend services very flexibly in a microservices ecosystem. The other nice thing is that this completely works on a specification. So the only thing that the federated gateway needs to know, it needs to know about the schemas of these different microservices and just the fact that they are there. So it knows, okay, there's Lolamo DGS that has a schema. That's it. There's no custom logic required to know how to talk to a Lolamo DGS because that's all just following the GraphQL standard. So this makes it extremely flexible for us to kind of have data owned by different teams, by different microservices, while from a consumer perspective, it's all in one really nice to use and flexible schema. Now, today we're just going to build one of those DGSs. So we're going to focus on just implementing one of them, but you should know that that is exactly the same code as what you would have in Federation. The only thing is I don't register my schema to a federated gateway, but other than that, it's all the same thing. Now, you might have heard about Spring GraphQL. So I've been talking about DGS so far, and DGS is the open source framework that Netflix created a few years ago. And then about 2 years ago, the Spring team published Spring GraphQL, which is kind of the official GraphQL API in Spring Boot. And you might be wondering, okay, what's the deal with those two different frameworks? Well, the deal with it is that DGS was there a little bit earlier. It wasn't part of like the Spring Boot standard ecosystem. Spring GraphQL is. But we've worked in the last 2 years with the Spring team to basically integrate those two frameworks, and now you can basically use them as one. So if you use the DGS framework, actually internally, a lot of it is built on top of Spring GraphQL, and you can mix and match the APIs and the features from both frameworks any way you like, basically. So it doesn't really matter which API style you use, they're very similar, but today I'm going to use DGS because that's what we use at Netflix. Okay, that's more than enough talk. We're going to look at how we actually build such a service, and that's kind of going to be the rest of the talk. And the service that we're going to build is basically a very simple version of what we call the LOLOMO. Hopefully you're all familiar with this screen. This is what we call the list of movies, because we have a list like your next watch, and a list of continue watching, and a list preview content, and each of those are lists of shows. So that's what we call the LOLOMO. And that's what we're going to implement. Obviously a very simple version of it, but I think that will be all right. So let's create a new project, and we're using IntelliJ and Spring Boot initializer. So we do LOLOMO demo. We're using Java 22 because it is 2024. I have to select the different technologies I need. So I need Spring Web. I could also use reactive, but I don't. And then we need, of course, DGS, which is the framework. And I'm also going to add DGS code generation. It's completely optional. If you don't like code generation, you don't have to. It works very nice without it as well, but it's kind of a nice to have if you want to use that. And it gives us our project here. And let's first take a look at a build.gradle. So with our CodeGen plugin, we have Java 22. That all looks good. We have our DGS starter. And I'm actually going to copy this and add one more dependency to it for testing later on. And then down here, we have the configuration for code generation, and we just set it up this way. And of course, it's a demo, so this doesn't work. Oh, I accidentally removed this. Okay, there we go. Not a good start, but that's all right. That's a lot better. Now, of course, the next thing we have to do, since it is a GraphQL service, is we have to write a schema. That's always the first thing you need to do. So we go to our source main resources, get rid of those directories, and I create a new file in the schema directory, and I call it schema.graphqls. And as I discussed earlier, the first thing we do is define a type query. And I said we are going to implement a LOLOMO, so kind of the obvious query to come up with is a LOLOMO query. And that is going to return a list of show category. And now, of course, we have to implement or define the type show category. Let's give it an ID, which is an int, a name, which is a string, and a list of shows. And then we define the show type with a title and also a artwork URL. It's kind of following the same example as what we had on the slide. That's all good. And with this schema, we can now start implementing this schema. And the first thing we need to do is create a data fetcher. So basically, we need a method that will be responsible for this LOLOMO query. Then we create a new Java class in the data fetchers package, and we call it LOLOMO data fetcher. And the first thing we do is we annotate a DGS component. It's kind of the same thing as what you have with add component in Spring and add controller and such things. This is just the specific one that we use for DGS components. And then we add a DGS query. And we call that public list show category shows. Not shows, lolmo. And what you just saw happen is that since I created this method, we now see this little icon here from the DGS framework, and it's actually from IntelliJ. We have a plugin for DGS, so we can click on it, and then we go to the schema and go back to the code. So it makes it very easy to navigate between your schema and all the components that you have in code. But now you might be wondering, okay, I just used this magic show category class. I didn't write it. Where did it come from? Well, that's actually code generation that's happening there. I had a Gradle plugin configured. And if you look at it, this is just a generated class from CodeGen. And it's basically just a Pojo, but we also get a nice builder class from it. Now, do you have to use this? Absolutely not. If you use instead Java records, for example, so record show, for example, that is almost as easy to use. And in many cases, that's actually what I use. You don't have to use CodeGen. But with CodeGen, you get a builder API, and that is pretty nice to have. So we're just going to use that now. So all we need to do here is just return a new list of show category, and this is where we use the builder. And let's start with just the ID and name. So this will be the top 10 category. ID is 2, and that will be continue watching. And this should actually be enough to get our service running. So let's start it. And once it's started, we can go to a browser, localhost 8080 GraphQL. And this is an editor that you get with every GraphQL service out of the box. So you just get it with Spring Boot. And one of the very nice things is we have a schema. So what we get in this editor is basically syntax completion on my queries based on the schema. So I have our lolmo query. And in the lolmo, so actually one thing to show, I wouldn't be able to execute this query right now because this is not a valid query, right? We haven't specified the fields that we actually want to get back. So I have to be specific about, okay, I want to get the shows. What did I do here? Name and shows. And on shows, on shows we get title and artwork URL. So let's just ask for the whole thing and see what happens here. So we see that it kind of works. We get our 2 categories back. We get our top 10 and we get our continue watching back. But we get null for shows. Well, if you look at our code, it actually makes sense because we obviously created those categories with the names of the categories, but we didn't have any show data yet. So that's kind of the next step that we need to fill in. But this is valid. It's okay if you get partial data back from GraphQL. Sometimes there is just no data. You will just get a null value. And the other thing that I want to show is if I would just remove this, now we just get the names of the categories. Okay, so back to the code. And what we need now is some shows. So this is kind of the obvious thing to do here. And to make this a little bit quicker, I'm going to cheat just a little bit and introduce a shows repository that just gives me a bunch of data because that would not be interesting to implement here. So we have a shows repository. And I'm just going to copy paste that from something I have prepared. So what this component does is just a component, and it keeps an in-memory list of hard-coded shows. That's all there is to it. And again, this is using the generated show type based on the schema. Of course, you can imagine this could be a shows repository sitting in front of a database, or maybe I do some external service calls, and actually that's something we'll do in a moment. But for the shows, for now, we just keep it super simple. It's in memory. I have this hard-coded list. And then I have my shows for category method, and based on the ID of a category, so that could be the ID of the top 10 list or the continue watching, I'm just arbitrarily returning a set of shows, because we don't really care about what this thing is doing as long as it's kind of, we can play around with it. Now also notice that I'm only setting the title of shows. I'm not setting artwork URLs, because that's where I'm actually going to call like another service later on. So we need our new shows repository, inject it, and now here we can just say shows repository, shows for category with an ID. There we go, let's restart this. And now we get our shows as well. But as expected, the artwork URL here is null, because I've set titles, I've not set artwork URLs. Okay, this all, hopefully it all makes sense. It is very straightforward. We just have the one Java method which is responsible for my one query. It returns the data that I give it. That's it. Now let's make it a little bit more realistic, and let's start thinking about this artwork URL that we need. So, of course, I could just go into my shows repository and say artwork URL, blah, blah, blah. But that would not be very interesting. And realistically, that would probably not be as simple in the real world. In the example that I'm thinking about, let's say that we're going to generate that artwork. So the artwork is going to be customized for whatever user is requesting this. And we're generating an image on the fly. I'm not actually going to do that, but that's kind of the use case. And that service will give me a URL to that just generated image, and that's what we're going to return. So there's like a bunch of stuff needs to happen. I would need to call another service. That will be extra latency, and how do we deal with such things? So the first thing that I want to do is I'm going to create yet another component, which is going to be the artwork service. That's also going to be a component, and it's going to have a public string generate for title with a string title. And let's say that we are actually going to keep it simple, but we'll get to how this actually would work. We take a random UUID and then use the show title. Just like that. So I'm obviously just running some other Java code here, but imagine this is actually going to do an external service call to another backend service, which is actually going to generate images and something like that. It could be maybe Spring AI. Maybe we ask an AI model to generate an image for us. And to emulate this mechanism, I want to do two more things. I want to have some logging statements, because that will be interesting later. So just print this, that this method is being called, generating for title. And the other thing that I want to do is introduce latency. So we're going to do a thread.sleep, 200 milliseconds, like emulating that we're calling something over the network, and that's going to take a little bit of time. And remember the API of this component. I can only generate a title for a single title at a time, basically. This is not a batch mechanism. I give it one title, I get one artwork URL. So if I have 10 shows, I have to call this thing 10 times. So how would we do this? Well, the simplest but worst way to do it would be in my shows here, I could just add the artwork URL. So I could call this service right here in my Lolemo method, and I would get those images for all the shows that I have and just put it on the data structure there. Would work. However, the problem that I would then get into is that if I run this and I don't ask for artwork URL, I would still generate all the images that I'm never going to use, and it adds like 200 milliseconds of latency for each and every image that I generate. That would be kind of a bad model. And we don't have to, because we have field selection, so we can be much more specific about when we are going to retrieve data for the field that we may or may not need to return. So instead of putting that code in my existing data fetcher, I'm going to create a data fetcher specifically for the artwork URL field. So we create a new DGS data fetcher, which is going to be DGS data in this case, which is a parent type of show. And again, we see this DGS icon, so let's click on it. And we see that this is a data fetcher specifically for this artwork URL field on the show type. And from there, we can now start to use our new component But now we run into a problem because, okay, I have my new data fetcher, that's cool. But I need a show, I need a title, because I need to know what title we are generating an image for. Now this is where you use the data fetching environment. And on the data fetching environment, we have a method to get the source. Now the source is in this case the parent type, so that is show. So to go back to the schema, Lolemo is going to return show category, which in turn returns show. But if you get to the artwork URL on show, we're calling our specific special data fetcher, and the source of that data fetcher is the show itself. So now we can show.getTitle and just return this. And hopefully, if we go back to our service and ask for artwork URL, we are now going to get artwork URL, but we also see that we have a problem. So yes, we got artwork URLs, that's good. This is the code that we implement in our component. But it's kind of really slow. This is not acceptable because it is like spinning there, and that's not a good user experience. And if I have 100 shows instead of 10, it would take 10x longer, etc. That's all bad. So you might be wondering, okay, when and how is this data fetcher going to be called? Is it all in serial? Well, the answer is clearly yes. But how does that look like? So let's get rid of this, run it one more time. You kind of see it in the logs, it's slowly dripping in. Kind of as expected, we're getting a generating for each and every of those shows, which also implies that this data fetcher here is called in serial for each and every of those shows. Now, very often, serial behavior is actually exactly what you want. You don't want to mess with threads when you don't need to, and if this was a very quick to resolve in-memory field, it's the best way to do it. There's no point in scheduling this on threads and using futures and all these things. But in this case, since I'm doing an external service call, I would definitely have to think about that. Now, one thing that I could do, kind of the traditional solution, is use a completable future and then go into the completable futures, schedule that completable future on an executor service that takes care of my threading. But now I have to figure out, okay, how big is this executor pool going to be? How do I tune that correctly? All that sort of thing. So this is what you kind of have to do if you're on any Java version before Java 21. But since we are on Java 21 or 22, in fact, I can do something better. And we can just go to our property file here and say dgs.graphql.virtual threads enabled true. There we go. Let's try this again. Let's click it again. Like magic, we now resolve them all in parallel. And if we go to our logging here, we see that each of those generating calls is all on a different virtual thread. So obviously this only works if you're on JDK 21 and above. But what we basically did is by enabling this feature, the DGS framework will automatically schedule each and every data fetcher on a different virtual thread. So this one will be a virtual thread. And then we have, if we have 10 shows, we have 10 virtual threads for this sub data fetcher. And that's fine because these virtual threads are super cheap. That's kind of the whole point of it. We don't have to care about like sizing the right thread pool and things like that. This just works. So this is a super easy way to get parallel behavior kind of out of the box without thinking about it at all, really, if you have this enabled. You do need to be aware that now your component is in fact running on a different thread. So if you do like context propagation and things like that of the security context, you need to be aware that you're running on multiple threads. The framework all nicely integrates that, but that is something to keep in mind. Okay, there's a different way we could handle this. Let's say that our component, instead of having a method that is like a single string, we could have an API for our remote service that generates images that gives that you can give a list of titles. So you can say, for this 10 titles, generate artwork, and it will give you back 10 URLs to 10 different images. If your API supports that, then that's kind of up to whatever team owns that other service, right? So it depends what you have. But if you have that, what we could do is use batch loading instead. And for that, we would use a data loader, it's called in GraphQL. And there you can basically say, okay, we do the same mechanism as what we have here, but instead of calling artwork service directly, we're going to call a batch loader. And that is going to collect all the IDs that we need to load for, and then it's going to do one call to the backend, basically. I'm not going to show that because I want to show a bunch of other things, but that is kind of the other mechanism that you can use depending on the APIs that you're talking to. So we have different mechanisms to optimize these fields. But I want to go to implement a different query. So let's also add search functionality to our service. And search is also going to return show. But of course it's search, so I need user input. I need an actual search query. So I could do something like title, string, that's fine, that works. But if you want more flexibility, I can also say, well, actually this is going to be a search filter, and it's going to be a complex type. And I can have maybe the ordering, and I can search on category of show and things like that. But we need to define that type. So search filter is going to be an input type. And for now, we're just going to give it title. So an input type is almost the same thing as a normal type, but in GraphQL, in the schema, you separate user input versus service output. And that's just how it is. The rules around what you can do with these types is almost the same. There's some caveats, but you do need to specify them separately, and that is a good thing. So now that we have our search filter, I'm going to run a build quickly so that we have our code generator creating this search filter type. And then we go back to the data fetcher and add one more DGS query. Public list of show. And again, the IntelliJ picks up that this is matching the schema. That's great. But we also get squiggly lines here. And that means there is something not completely quite right. And IntelliJ is telling me that, well, in your schema, you have this input argument defined, but it's not in your code. So probably that's something wrong. Maybe not. Depends on what you want to do with it. But I'm going to trust IntelliJ, and it's generating this input argument of search filter. And again, this was just generated by code generation based on the schema. And for this one, we're just going to go to the shows repository, get all shows, .stream, filter, show.get title, starts with, search filter.get title. And of course, I should take care of null checks and all these things, but I'll just leave that for now. And that's it. And I'm actually going somewhere with this. But let's first test this out in the browser. Refresh, search, and now I can have my input here as search filter, and just have my title is, let's say, D. So show starting with D. There we go, we get two shows. And one thing that is kind of nice is that it was super easy to implement this data fetcher because I already had the show type, I already had my data fetcher for the artwork URL. And since I'm just reusing the show type, although previously I was returning a show category, now I'm just directly returning show, all these data fetchers already just work, and I don't have to implement any extra logic for that. So my artwork is still using the same code that we already had, and now it becomes very easy to compose these different data fetchers. So this is not completely surprising. One other thing that I quickly want to show here is that now that we have two queries, we can just add them in the same query. So let's say that I both want to do a search and I want to get a Lolamo. I can put them in the same query here. And in the response, we get the search and the Lolamo with its data. And this is kind of where you start to see the flexibility of GraphQL APIs. Because depending on the UI that I'm building, I might need those two fields at the same time, while another device only wants to do search or only wants to do Lolamo. And I have all this flexibility, including the field selection, that you can play with. So we have all these things at our disposal. Now, so far we have just been playing around with this service by just going to the browser and trying a query and see that it works, and it's all great. But of course, we also should have some automated tests. I don't want to just keep testing this thing in the browser. So let's write a test. So create a new test here. Let's focus on search. And what I'm going to do here is make this a Spring Boot test. But I don't want to start the whole app. Actually, it would be fine for this app. It takes like 2 seconds to start up, so it's not a big deal. But in any real application, you have like a database, and then there's Flyway for whatever reason, and there's maybe warming of IPC clients, and everything takes a little bit of time to warm up. And before you know it, you look at like 30 seconds of startup time, and now you're unhappy as a developer. Which would imply that my test is also taking 30 seconds. So instead, I just want to specify the classes to include in the test that I'm actually interested in testing right now. So that is going to be our Lolamo data fetcher, artwork, service, and show repository. But we also need a DGS framework because I want to send it an actual query, an actual GraphQL query to do the test. And that means we need to be able to execute that query. So we use a test slice here to basically set up the core of the DGS framework. Now, it's things like Spring Boot test and test slices and all these things are kind of new to you. I have another talk tomorrow that is all about testing and how we test our Spring Boot apps at Netflix. Goes into all those details. So you should definitely come back for that one tomorrow as well. But given this setup, we can now auto-wire a DGS query executor. And in the DGS query executor, we can just write a query as a string. And I'm going to annotate this, this string with add language, which is a feature from IntelliJ, and say this is GraphQL. And now we actually get syntax completion in a string based on our schema. So that's very nice. It's not compile time checking, but it is very, very helpful. So we have our query. We do a search with a search filter, and we need a title. And look at this, I'm going to do a lowercase d, while just now in the browser I did uppercase d. And you might have spotted a bug in my code earlier, and that's kind of what I want to get to. So we ask for title here. And based on this query string, I can now use the DGS query executor to get a list of just titles. That's what I want. We have all sorts of utility methods on the query executor to execute a query and then do something with the response. So we do execute and extract JSON path of the query. And the second argument here is a JSON path that gets just the titles out of the JSON response. So we had search, which is a list title. And given this, we can now do a assert. That checks if titles contains exactly the Witcher and the last dance. Now you might now already expect that this test is actually going to fail because I have a bug in my code, and that is exactly what I want to show. So, oh, there we go. If you look at the output of the test, we will see that, well, I'm actually getting an empty array instead of the expected 2 shows that we were looking for. And if we look at our data fetcher, that will actually make sense because I am case sensitive here. And my shows happen to start with uppercase d while I'm searching for lowercase. Now we can, of course, easily fix this with some lowercasing. And we verify that the test is now again working. And we see that it is working. What we also see is that this test is incredibly fast. It is as fast as a unit test because it's almost like a unit test. We bootstrap the dependency injection core from Spring Framework. We bootstrap our 3 components and the DGS core. That's it. So these tests are super quick. And this is how we test most of our GraphQL components at Netflix as well. You want to go through all the query execution stuff. You don't just want to look at it as a Java class. But it is a really nice trade-off between test speed and complexity and actually testing something useful. And again, more about that tomorrow. Okay, I think that is enough for kind of playing around with the code. There's of course a lot more to the framework. So I'm just pulling up the docs here. It's kind of the getting started. You have seen how easy it is to get started with just Spring Initializer, create a new project, add DGS, and you're off to go. This goes in all the details, how we now nicely integrate with Spring GraphQL and how you can mix and match the APIs and the different features. That all works very nicely. There's all the details around data fetching. That's kind of what we have seen so far, but then there's also all sorts of more advanced tricks you can use. You can do like a look ahead, where you check for, okay, was this field requested in the query, and then use that information in the first top level data fetcher. That's a useful thing to do. You can do mutations, which is kind of the same thing as a query, but now you send data to the server. So that's basically your updates and your saves and things like that. Data loaders are definitely something you should look into. That is where we can do batch loading and be very efficient about how we call other backend services. Things about federation, if you have a federated gateway, and then all sorts of more advanced topics that you might need. That is about all the time that we have. So I want to thank you all for your attention. And there's a link to the GitHub repository, which also links to the docs. And go try it out.
How about now? All right. We have a few minutes for some questions. Do we have any questions here? Come on, you got it. Oh, there we go. We got a question.
I'm not the developer. I'm the security guy. Do you guys have any follow-ups with securing this GraphQL? Because they're starting to use it, but they're leaving it wide open in dev. So
Yeah, so at Netflix, we have many levels of security when it comes to GraphQL. So the first one is like the very basic, like out Z and out N on your endpoint. So on the /GraphQL endpoint, which is like, are you even allowed to call the service? That is step one, but that is very, very coarse grained. But that is like the first thing that we can cut off traffic. And it actually happens at every level of the server. So you have the gateway, and that calls another DGS. At every level, that happens again. Then at each data fetcher, we can use Spring Security with, for example, the @secured or the @pre-authorized methods to say, okay, only this role is allowed to call this data fetcher. And it immediately gives you the flexibility to be specific about what fields and what queries a specific user or role is allowed to call. We can just do that with annotations. That's an option. And then there's a really powerful mechanism in GraphQL which is called instrumentation. And basically you can inspect and execute code on every part of the query execution. So for every field, for example, you can call your own code. And that is very easily can implement more advanced security mechanisms that if you, for a very specific field, for example, you want to do something extra when it comes to security, very easy to implement with just some Java code. That's our implementation of how we implement the security. That's of course internal to Netflix, but the hooks are all in the framework, and that's the same hooks as what we use. So the actual checks are not there, but the mechanisms are.
All right.
Okay, this is kind of a process-oriented question, but how did you deal with the challenges of validating that your deployed software met the appropriate governance model?
Repeat the last bit of it.
How do you deal with the challenges of verifying that your deployed software meets your governance model?
Yeah, that's a great question. So we have a schema, and that schema is going to be, I think that's what you're asking about, right? How do you have a service that actually conforms to the schema? So I spoke earlier about the federated gateway has the schema of all these different DGSs. That means that each DGS has to update their schema in the registry. And when that happens, there's a whole validation process happening, all automated, that checks, is your schema valid, first of all, in the federated schema, but also, do you have any breaking chances? And if there's any breaking chances, you're not allowed to push. Unless you go through like a deprecation phase and you go through the steps to actually get rid of a field, but you make sure that the schema never accidentally breaks. And that means that the only way to get something deployed is to have a valid schema that composes nicely in the federated way. So that's all checked. Yeah.
Awesome. All right, no more questions? All right, thanks, Paul. Appreciate it. We'll take a short break and be back with Sebastian.
Thank you.